let's move along in lesson 5. They're going to ask us today, our goals today are to use inspection, tables, graphs, and algebraic properties to solve linear equations. And then they want us to determine the reasonableness of our solutions to linear equations in given contexts. And that's that whole notion of being able to estimate, did my answer make sense? And then also we want to be able to move along from there and actually check it. There's always a way to check when you're solving equations. It's a nice part of the study of mathematics. You should never miss a solving equation because you have a check. So let's look at, and it's going to, my computer's acting weird here this morning, so it's going to take a moment and we'll wait for it. But you're going to see in this animation in slide 3, page 3 here, the same equation that we had before involving the 2x plus 5 equal to 11. Hopefully it'll pop up here. So let's read along here. It says this: you've learned that you can think of an equation as a balanced scale. When you apply the properties of equality to an equation, the scale stays balanced. But why? Each time you apply the property of equality, you create a new equation. So that's an important part of this, and you're going to see that in the next part, that there's lots of ways that you can represent 2x plus 5 equal to 11. That is creating equivalent equations. Key vocab term there, you might want to write that one down in your notes. But equivalent equations are equations that have the same solution set. So this equation tells you that what was done to x to get the output value of 11. So we know that this 2x plus 5 on the left side is equivalent to that value of 11. So they're showing you, in essence, what this left side is to get to that result of 11. And there's a process. And to solving this, we're actually going to go in opposite order. And this is where that whole idea introduced of PEMDAS working in reverse. So addition and subtraction are last in PEMDAS, but notice we're going to work up the action results and go in opposite order to give that idea of undoing. And so identify, you should see that there are actually 3 equivalent equations. The beginning one, there's a middle one after that first step, and then a last one. They're going to show us, and they're going to talk about that here in a sec. By the way, I really encourage you to step through these animations on your own time to make sure you fully understand what's happening here. And they're going to tie back to a processing of solving we've used in the past. You have those 3 equivalent equations. They all have the same solution set. And the graph, so look at that again. Them showing the graph confirms that we always get this solution of 3. Looking at where those 2 lines cross. 2 lines are created each time. Remember that from your graphing processes. Okay, I encourage you to jump into the textbook now and take a look at these 2 problems, 1 and 2, based on this animation. All right, I will see you guys in the next video.